In this lecture, we will be answering the question, how are matter and energy different? Well, let's start off with an analogy. What does every sentence have to be a sentence? Well, to answer this question, let's consider the following sentence. Students learn. In this sentence, I have a noun or a subject in the word students, and I have a verb or action in the word learn. All other words in the human language are just describing or connecting the subject or thing and the verb or action. So here you can see I've added a lot of words to our first sentence. I now have, the clever students choose to learn in the most delightful way. I still have a noun or subject and a verb, I just have a lot more words there connecting the two of them. You're probably thinking, why in the world are we having a grammar lesson in a science lecture? Well, it's because the universe is similar to a sentence in the fact that we can divide everything into two categories, either things or actions. Things are kind of like our noun or our subject, and actions are like our verb. But we have some more scientific language for this. So in science, what do we call things? If you said matter, you'd be right. Anything that's a thing in the world is known as matter, whether it's an airplane or people or a hot air balloon or air or water. All of those things are matter. But the universe would be really, really boring if all we had was matter, because it would just sit there, right? It wouldn't be very interesting if an airplane just sat on the runway or a person just sat in the chair all day long. So pause and take note. In science, what do we call actions? Energy. If you see somebody jumping through the air or a roller coaster going down its coast, all of those things are energy. Energy is what makes things move, go, work, change. It's what makes life more interesting. So pause and take a note. As far as we know, everything in the universe is either matter or energy. Everything can fall into one of those two categories of either things or actions. It's either matter or it's energy. Pause and take a note. Okay, let's look at our properties of matter. This is something you've probably learned a while ago, but let's just kind of review. So first up, we have that all matter is made of particles. Second, that all matter takes up space. And third, that all matter has weight. Let's look at each of these properties a little bit in detail. First, all matter is made of particles. So let's say I have a wooden table and I'm going to sand down part of that. What am I going to get? Well, I'll get sawdust. Am I changing the wood? Am I changing what it is? No, it's still wood. I've just changed its form. And with the sawdust, it is still a thing. I can pick it up, I can hold it, I can feel it. It's still matter, but it's not quite in the same form of that table. Well, we can think of matter like this, that it's made of particles, smaller things. The sawdust is still the wood, but now it's a smaller form of the wood. And if we took that sawdust and we put it under a microscope, we would be able to see even smaller parts of that wood. So all matter is made of particles. It's made of smaller things, whether it's solid, liquid, or gas. Next, let's look at the next property of matter, that all matter takes up space. Whether it's solid, liquid, or gas, it takes up space. If I have a box and I'm going to fill it with solids, there's only so many things I can put in there before the box becomes full. Same with a liquid. If I have a water bottle, I can only put so much water in there before it starts to overflow. Or if I'm blowing up a balloon, there's only so much air I can put in there before the balloon is going to burst. In all of these instances, it shows that all matter takes up space. Next, all matter has weight. If it's a solid, I can very easily put it on a scale and see how much it weighs. If it's a liquid, I can put it into some form of container and weigh that and figure out how much the liquid weighs by subtracting the weight of the container. Same with a gas. I can put that gas in a container and weigh that and figure out how much it weighs. All matter has some weight. It might be a lot if it's a car. It might be very, very little if it's a gas. But the important thing is no matter what, if it's matter, I can weigh it. But let's think about energy. How is energy different? Is it going to follow the same rules as matter? I'll tell you right now, it's not. One rule that it doesn't follow is that energy does not take up space. To help us with this, let's look at a few examples. So, can you put light itself in a container, cover it, take it into a dark room and let it out? No, of course not. You can't do that. Why? Because light is a form of energy, and energy does not take up space. Let's look at another example. Can you blow up a balloon with light? Again, of course not, because light is a form of energy, and energy doesn't occupy space. One more example. Does a bucket sitting in sunlight fill up and overflow with light? No, again, because light doesn't take up space. If I left that same bucket outside on a rainy day, it would fill up with water and overflow. But that's because water is matter. Light is not, and it does not take up space. Pause and take a note. Let's look at the second property of matter and see what energy does there. One thing, energy does not have mass. It cannot be weighed. So let's look again at a few examples to help us explain this. Is a ball heavier or larger at the bottom of a ramp than it was at the top? No, of course not, unless the ramp is made of something like snow or salt, where the ball is going to be picking up some matter along the way, because energy does not have a mass. Let's look at another example. Does a compressed spring weigh less when it's not under tension? Again, of course not, because even though it looks differently, we have not changed its matter at all. All we've done is put energy in, and energy does not have a mass. Next example. Does a battery get smaller or lighter as electricity is drained from it? No, it doesn't. If you find a battery in a drawer at home, you can't figure out by weighing it how much energy is left in it, because energy does not take up weight. So, now we can come up with a list of what energy is not. First, energy does not occupy space like matter does. Second, energy does not have a mass or a weight in the same way that matter does. And finally, energy is not a substance and cannot be seen or weighed. Pause and take a note. So now that we have a list of what energy is not, what is energy? Well, it's what affects matter. It's what causes matter to go, work, move, or change in some way. Pause and take a note. So going back to our analogy at the beginning of this lecture, matter is to energy as noun is to verb, meaning that matter is like things, energy is like an action. Again, noun is like a thing, and verb is like an action. Pause and take a note. There is one similarity between matter and energy, and let's look at matter first. Matter can change to a different state of matter. Let's take an ice cube. An ice cube is a solid. If I put it in a glass and leave it on the counter for a little while, when I come back a bit later, it will have changed into a liquid. Is it still water? Yes, but it has changed from its solid state to its liquid state. Now let's say I leave that glass with the liquid in it, the liquid water, overnight. When I come back the next morning, what will have happened? The glass is going to be empty because the water will have transformed from a liquid state to a gas state. Is it still water? Yes, it's just that it's a gas in the air. Pause and take a note. Well, energy is in the same way. It can change between forms of energy. So electrical energy can be transformed into heat or thermal energy when I turn on my stove. Or electrical can be transformed into light or heat energy when I turn on a lamp at home. Again, electrical energy can be transformed into light, heat, and sound energy when I turn on my TV or computer. And electrical energy can be transformed into movement, heat, and sound energy when I plug in my blender. Pause and take a note. An important thing to note in all of this is that matter is not going to be changed into energy, and energy is not going to be changed into matter. Matter can change into a different form of matter, and energy can change into a different form of energy. But matter is not going to change into energy, and energy can't change into matter. Pause and take a note. There you have it. Now you know why matter and energy are different.